Hi students, in today's class I am going to explain about Hess law, heat of summation. Actually, this is a most important question for your IP examination. If you get this question in your examination, you just try to write as it is, you will get full marks. Now let's start that one. First, you can write Hess law definition. I am discussing in that view only. That means in the point that the point is nothing but in the view of IP examination. Just remember, okay? Hess law. The heat change in a chemical reaction is equal to the heat change in a chemical reaction equal to whether the chemical reaction CR nothing but here chemical reaction takes place in a single step or in several steps. Just remember this. This is the definition for Hess law of constant heat summation. Just by taking general example, try to understand what is this one. A converts into D. A is the reactant here, D is the product. During this reaction, some heat energy will be released. That heat energy indicates with the capital Q. You can imagine this is the path 1 for the formation of product D. If the same reaction happens in several steps, that means if you are going to any child, small child, he or she, if you are asking where is your nose, some children showing like this is my nose, but some children are showing like this is my nose. Do you have any objection like that? So here first our hand going to push up, this is step 1, then step 2, then step 3, then step 4, like this. At last we are, she is reaching her hand, she reached her hand to her nose or his nose, like that. Here also A to B, A to B, one product, from B to some another product, that is C, and then C to D. See, A to B, B to C, C to D. This A to B is the step 1, you can imagine. B to C is the step 2, C to D is the step 3. In all these 3 steps, some heat energy going to be released. That heat energy indicates with minus Q1 for step 1, minus Q2 for step 2, minus Q3 for step 3. Just remember. Then we just try to write this representation in a chemical reaction form. See, that is path 1, you can write first path 1, conversion of A into D. Here some heat energy released indicates with delta H, that is equal to the capital Q. Then path 2 you can take. Path 2 happens in 3 steps. 3 steps. Step 1 you can write. Step 1 is formation of B from A. Here the heat energy released indicates with delta H1, that is minus Q1. Step 2 you can write B to C, that is indicates with delta H2 equal to minus Q2, and step 3 delta not delta, C to D, that is delta H3 equal to minus Q3. So in all, I mean, in the case of path 2, you can add all these three steps: 1 plus 2 plus 3. So what will you get? You can see C cancel, B cancel. So remaining will be A to D, A to D, delta H1 plus delta H2 plus delta H3 equal to Q1 plus Q2 plus Q3. Okay. This delta H1, delta H2, delta H3 equal to the delta H directly. You can write. So this delta H equal to capital Q minus capital Q. That is equal to the minus of Q1 plus Q2 plus Q3. This is the general representation for Hess law of constant heat summation. You just try to write this one or take a screenshot. Then we will take one live example for better understanding. Example you can take formation of CO2 gas from carbon and oxygen. Okay. Path 1 you can take that is the single step reaction. Carbon in the form of graphite reacts with oxygen. 1 mole of oxygen gas will form CO2 gas. Here the heat energy indicates, released heat energy indicates with delta H, that is minus 393.52 kilojoule. You can remember this is the single step reaction in path 1. Path 2 you can take carbon in the form of graphite, that is in two steps, step 1 and step 2. Graphite plus half mole of oxygen gas reacts, then they will form carbon monoxide gas. Here the heat energy released indicates with delta H1, that is minus 110.5 kilojoule. Okay. Next step 2 you can write carbon in, I mean the carbon monoxide formed in the step 1 reacts with half mole of oxygen gas, then they will form CO2 gas that will indicates with the heat energy delta H2, that is 2 minus 283.02 kilojoule. So the next one is what? You can add 1 and 2. 1 plus 2 reactions in the path 2. So you will get, say, this CO and this CO will cancel out with each other. So the remaining one is carbon in the form of graphite plus half O2 gives you 1 mole of oxygen gas. Then they will form CO2 gas. See, this one is equal to the path 1's reaction. This reaction equal to the path 1's reaction, and then come to delta H1 plus delta H2 equal to, you can add these two values, not 3, only 2 values. See, 0 and 3, 9, this is 3.52 kilojoule. See, delta H1 and delta H2 equal to minus 393.52 kilojoule. So that one equal to the delta H equal to minus 393.52 kilojoule. See, this one, this indicates Hess law. What Hess law tells us? The heat energy change in a chemical reaction. If the chemical reaction takes place in a single step or in several steps, the heat energy change is equal. That means here see path 1, heat energy change, enthalpy change, delta H indicates the enthalpy change equal to minus 393.52 kilojoule. Next, if the same reaction takes place in different steps, that will also gives minus 393.52 kilojoule. So if you get this question, just try to write as it is, you will get full marks. Thanks for watching. We will meet in the next class.